Yeah, good evening, everyone. Your host today is Juma Lawrence. Today, you're going to have the normal SIT Tech Talks, which is a session that we hold every Saturday evening to talk about different tech stacks and technologies. So, on today, and the session is brought to you by the Tech Community and Mentalist Product. So, today, you have a speaker today who is going to be facilitating the session today is Byran Kai, who is a data analyst. Maybe he'll introduce himself more as you're going to start the session. Uh, Kai, the floor is yours as you take up the session.
Okay, thank you, Juma. Hi, everyone. Hi, Benson. Hi, Amos. Hi, A. Jacinta. Hi, Lillian Bonnet. They're the ones I'm seeing on my screen. So, yeah. Hi, everyone. You can just reply with one if you had a great day in the chat section. So, yeah, I'm joining in with my laptop, but my laptop seems to be having issues with sound. So, I'm presenting with my laptop and speaking through my phone. So in case I'm having issues, please Juma just give me a call and let me know maybe if I dropped off or something because I don't know. Yeah, so that's it. I'm also I'm also nervous. I have to be honest. I've done this many times, but I still get nervous when I have to speak. No, so yeah, but thank you everyone for joining. I'm really happy. It's at least 10, 19 attendees. Thank you everyone for joining. So Juma, should I just go ahead or we are waiting for others to join?
Yeah, we can sort of then they'll join us as the session is on.
Oh, okay. Sure. So hi everyone. Welcome and thank you for joining us. We and I am so glad that you could make it to this session. I am really, really happy that you made time to come and listen to me. I hope by the end of this session, you will be able to apply machine learning to your tabular data. So since that is the topic of today's session. So yep. Oh, I usually have this recording disclaimer. We will be recording this talk and we have already started recording and we'll share it with all of you after today. During the presentation, we ask you to add your question to the chat section on the right and refrain from asking any questions in person until at the end. So this is just a I will respect your privacy and I'm just sharing with you that if you decide to unmute while I'm presenting, then you automatically consent that your voice or maybe even your video will appear on the recording, which will be shared publicly. So you can, of course, ask a question when I'm still presenting, but this is just to share with you to respect your privacy, of course, that we will be sharing this publicly and you might appear in the session in the recording. So we have a moderator that is Juma Alan, not Juma Alan, sorry, Juma, who will be able to answer your questions in the sorry, will answer your questions in the chat section through the presentation. But yeah, I will also be checking the chat section. Also, after this presentation, we'll stop recording and you can have a private Q&A after where you can unmute, even open a camera and you can ask me live questions. Thank you for understanding. Please make sure you're on mute and enjoy the presentation. So yeah, that's just a little disclaimer and to show that we respect your privacy. So yeah. So today's session is streamlining data analysis with simple ML for Sheets. So Simple ML for Sheets is a it's an add-on on the Google Sheets that you can use to incorporate machine learning to your tabular data that is on Google Sheets, and that is what we'll be discussing today. So if you're a data analyst and you maybe don't understand the deep concepts of machine learning, or if uh, you're just not even into tech, but you just want to bring the power of machine learning to your Google Sheets. Also, if you're just a community manager and you just want to analyze the attendance of your members, or you want to do maybe, let's say, some forecasting on your data, you can do that with Simple ML for Sheets. Given that it is simple, also if you have very strong knowledge in machine learning and data science, you also can use machine learning, and I will be sharing that in today's session. Also, we had latest updates in Simple ML during this year's Google I/O, and I'll also be sharing with you that, and we'll try that together in this session. So yeah, thank you very much. So I am Byran Kai. I'm a data scientist and open source advocate. I love open source. So yeah, that's me. You can reach out to me on Twitter at Kai_Manyumba or on LinkedIn at Byran Kai. So yeah, let's get right into it. So the agenda for today, first of all, I will explain to you what tabular data is and what non-tabular data is. But our focus for today's session is tabular data, of course. Then we will talk about what are decision trees, since decision trees are the ones that power, is the algorithm that powers simple ML for sheets. So it will be good for you to understand just a little bit. So we'll be talking about just a little bit of machine learning, and I will try to break this down to a very, very, to, I'll try to break this down such that even a to explain to you like I'm five, like, the way a child explains to you something. So yeah, I'll try to break down the concepts because I understand maybe most of us in this session are not machine learning experts. So I have that in mind. So don't worry. Also, feel free to drop your questions if you don't understand anything, or just raise your hand and Juma will let me know, of course. Also, we'll be having live demos. So I'll be taking you through 1, 2, 3, 4 live demos on the use cases of machine learning, that is forecasting data, the predicting values, also maybe building a model for those who have deep understanding in machine learning. So, yep. So now we for us to start out, we need to understand the basic terms before we move ahead. So we have, can you explain features in your data set? So a data set is just a bunch of data organized in a way that you can access and query them easily. So let's say I'm hosting an event. So for example, we have Google I/O extended for students coming up. So the organizers are hosting an event, and then we have you are SVP on their platform, and then you say your name, and then where you come from, which university you are coming from, your gender, and so on and so forth. So that is just data that will be organized in a tabular form that they can easily query to check you in during the event. So that is data. And then we have features in a data. So we want to understand what features are. So you can explain a feature in a data set as a characteristics about these are characteristics about the data that is in our data set. For example, let's say uh, Juma always keeps records of all the speakers that speak at Speciatech talks. So we have the name column, the gender column, the talk column, and the stack column. So let's say now my name will be Brayan. So my name will be Brayan, and I'm a male. So the feature will be male. Then I'm a speaker. Then you have attendees and all that. So those are just features in our data set. So let's go ahead. So I've said that we'll be discussing about tabular data, but first we need to understand what is tabular and what is non-tabular data. So up to there, are we all in the same page? Maybe you can just reply with one in the chat section. Of course, this is not me talking to you, but you're all talking to each. We are all, let's make this a conversation. So, yep. Okay. Thank you, Eugene. You can also just do a thumbs up, the emojis. It's giving Gen Z vibe. It's giving what it's supposed to give. Yes. Thank you. Yeah. Okay. So for the first example, which you can see here, so this is the first example. So this is tabular data. So we have columns which have features, and we have rows with examples. So for example, this is a column that holds the address. This is a column that holds the income. This is a column that holds the age, and this is a column that holds the education. So I can easily know that, let's say my address is 123 ST, my income is 50K, my age is 40, and the highest level of education I've attained is high school. So once you look at them, you can explain each feature. Like you understand that 50K means I'm earning 50,000 Kenya shillings per month. Age, that means I'm 40 years. When I look at this feature, I can get meaning out of it. So, but let's look at these images. So we have these images. So But if we look at an image, the features of an image are pixels. So that's why you see, like, if the team pixel, it's very quality pixels. So, okay, that was just by the way. So, but in images, we describe images through pixels. So when you look at images, you see like this here is a pixel and this here is a pixel. So we can't really describe, we can't really understand or fathom what this pixel contains once we just look at this. So we really can't get it. Maybe for those who have done neural networks, they understand maybe deeply what I say when we can't really comprehend what is in one pixel. For example, when I really zoom a picture to 1 pixel, can I get a meaning out of it? Of course, no. I can't get a meaning out of the same. So that's why I'm saying it's easy for us to easily understand what this 50K means here compared to what this pixel means. Because if it's a color coding, I have to go and check maybe what color is this. For this one here, I have to also go and check what color is this. So that is just it. So here is just more of, we can't get meaning from what a feature is. So tabular data is also known as structured data because you can explain all the features that are there. So you can easily explain all the features. But for unstructured data, it's more of pixels and maybe letters, or let's say sound waves. You can't really just look into it and get to know what it means. So when you talk about simple machine learning or decision trees, which are the best algorithm of what simple ML does, we are talking about the world of tabular data, and that is what we're going to be exploring today. So let's go ahead. So I mentioned that what makes up the base algorithm, what makes up the base of simple ML for sheets are decision forests or decision trees, because of course we know trees make up a forest. So we have many trees that will make up a decision forest. So now let's take a look at what exactly decision trees are. So we have different types of machine learning models or algorithms. And what you're seeing on your screen right now are just two examples. So we are seeing an example of a decision tree here and an example of a neural network on this other part. But this is just to give you an overview. I understand maybe this is just to give you a base overview. We're not going to go that deep into neural networks, but we'll just go a little deep on decision trees. So decision trees, they they they're just a bunch. As you can see, just like maybe for those who, it's just like who did biology in high school. It's more of dichotomous key, just to make it very simple for all of us. If we did biology, there's a topic in, I guess, Form 4 that talks about dichotomous key. So it's just as simple as that. It's just a number of this, or a set of decisions that let us see what the output is. For example, here I'm saying if the number of legs are greater than or equal to 3, if it is yes, then go to this decision. But if it is no, then that is a penguin. And if the number of the eyes are greater than or equal to 3, then that is a spider. Or if it's no, that is a dog. So that is just a simple decision concept that you're having. So you define conditions, and these conditions are applied to the features of your data. So here you have an examples of a decision tree. Here we have an advantage in decision tree since it's explainable compared to other black box models. So from here you can see that I can easily explain how I came to the answer spider, or how I came to the answer dog. I know that the number of legs are of course greater than or equal to 3, then the number of eyes are also greater than or equal to 3, then that is why I say this is a dog. But on the other hand, we have what we call neural networks. So with neural networks, it's just a different perspective. It's a whole different perspective compared to decision trees. So here in neural networks, we're trying to apply many metric transformations to the input data such that in the end, you have a result you want. So you just apply a lot of metrics to your input data such that in the end, you have what you have. So this is a way more complex algorithm. You can check it out. I did a session with Google Developer Students Club Unilac. I'll just drop, if you want to know more about neural networks, I'll just drop the link in the chat section probably later. But today we'll be focusing on decision trees because that is our aim for today's talk. So yeah, now we are here. Now we are talking about decision trees. But what is a decision tree? So a decision tree, as I mentioned, is just a collection of conditions and you have them organized in a sequence. So you see, like, you have them organized in a sequential manner. So we have the first node here, like the first condition constraint that you provide, we call it the root. So let's say the number of legs is greater than or equal to 3. That is, we call it the root. Then we have this is the first node here, and then the last node which holds the decision, we call it the leaf node. So this is basically so different compared to what a real tree is, because in real trees the roots are at the bottom, but here the roots are at the top and then the leaves are at the bottom. But just to give you an understanding, this is just a basic overview of decision trees. So you can see, like, for here, this is a non-leaf. We call this the root node. Then this is the non-leaf node, which contains number of eyes is greater than or equal to 3. And then this is the condition that you're having. If it's a no, then it's dog. If it's a yes, then it's spider. Then if the number of legs is that, we have it as a penguin. So one of the advantages, again, as I said, is that you can easily understand what your model has given and what are the features that it has incorporated to give you the answer. And one of the advantages of decision trees is that it makes predictions very fast. So you can see we don't have a lot of, you see, not maybe layers we are working on. It's just yes, no, yes, no. So it is, the algorithm is very fast. So here the training process we are having is just creating the decision tree based on the data. So that is what we'll be doing. And making an inference is using those trees to asking a question. So when I'm training my data, if I'm training my data, then that means I'm trying to get a decision from that data using a set of conditions. Then when I'm making an inference, I'm using those trees to asking a question, i.e., what's the row? What row is it? Okay, like, let's say here I'm asking a question, what are the number of legs that make up a penguin? Is it greater than or equal to 3? Then if it's greater than or equal, it's not greater than or equal to 3, I say it's a penguin. If it's greater than or equal to 3, then I go down and I get my answer. So yeah. So a decision tree, trees make up a forest. But as we all know, when we come together, great things happen. So that's the same answer for decision trees. When more decision trees come together, that means we are having a more accurate answer. So as you can see here, a decision forest is a set of decision trees that work together. So you can see here, for example, this is tree number 1, then this is tree number 2, then this is tree number, let's say we have n number of trees. And in this n number of trees, I give them data, then I try to let them give me a prediction. So tree number 1 gives me A, tree number 2 gives me A, and tree number N gives me B. So now what we do with decision forest is that we vote. So if we say the eyes have it, so if many trees tell me it's A, then my decision will be A. If many trees tell me it's B, then my decision will be B. So for example, here we see have tree 1, tree 2, and tree N. So for the 2 of the trees tell us it's A, and 1 of the trees tell us it's B. So we vote and see that A is the most appearing one, so we give our prediction as A. So you can see that this is more accurate compared to just having one decision tree, and it helps us get a more accurate decision compared to just using one tree. So I hope now you understand the difference between you have the basic understanding of what is a decision tree and what is a decision forest. So yep. Okay. So we've mentioned about decision forest, but what are their advantages? So number one, it has excellent quality. So for tabular data, as of today, like I don't know, maybe we can have researches that can come up, but as of today, decision forests are the best algorithms for any tabular data. Like you can, yes, people try to do neural networks, you have transformers, all those, but everything you can imagine, they don't get everything, even if they go to that such a whole complex process of coming up with a transformer, they still get the quality that decision forest gives. So it still has one of the highest, provides the highest quality. Then it is easy to train. They have a way less needs for pre-processing. So we can imagine here just making decisions. But now if you've done neural networks, you understand that we need to have an input layer, then you have hidden layers, then you have an output layer, then you have weights, biases, all those just to come up activation functions, just to come up with one and just one prediction. But here you just have a set of conditions, they just give us an answer. So you see, it is way much easier and it's so easy to train compared to all the other algorithms. Of course, it is very fast. It just takes a couple of seconds for large amounts of data. We'll see this when I'm doing the demo. It just takes a few seconds. We'll actually count together a few seconds to just provide us an answer for, let's say, 2000 rows of data compared to what we'll be doing with epochs in neural networks. So, yep. Another one, it is interpretable. As I've said, it is easy to interpret because you can just look into the decision tree and understand that's why it's giving you such a result. Because, for example, here you can just look at it and see that it is giving me as a dog because this input has greater than 3 legs and has greater than 3 eyes. So, just as simple as that, you're able to interpret what your decision forest has. So, yeah. So now we have different types of decision forest. So we have the cat, the random forest, and the gradient boosted trees. So for the cat, this is just the cat is the decision tree algorithm, just one decision tree. One. We've said trees make up a forest, but now for the cat is just one decision tree. Like it's just one tree giving us the output. For the random forest is what we call wisdom of the crowd. So here, let me just give an explanation. So here we have many trees. For example, we have, let's say, 500 to, let's say, 1000 trees, and all of them are trained a little bit different though, and they give a result, which is now my model. So this model now doesn't contain only one tree compared to cat, but contains many trees that now give me my prediction. So it is a little bit different. It is a little bit different since all the trees are trained in a different way, and they give us a different answer. And they give us a different answer. Then we do voting, and then we come up with our prediction. And then now we have the gradient boosted trees. So for the gradient boosted tree, this one is now a little bit different, but let me give you a very simple analogy that will help you understand. So imagine you have an expert in something. So let's say, let me give you an example that you can easily understand. Yep. So imagine you want to learn Angular. So the one person that you'll go to is, of course, this is just an example, not that I'm biased, but we have Wayne Gaku, who is a GDE in Angular. So you will easily go to Wayne. But now, once you build your Angular application, you notice that you want to also include machine learning in your application. And you then notice that Wayne doesn't understand machine learning in such deep concepts. So Wayne sends you to Muiti. So Muiti is also a GDE in machine learning. So you go to Muiti to help you with machine learning. Then after that, now you also come up, you've built your Angular and you have your machine learning integrated. But now you also want to share this to your community. And now you have to find someone who is good with communities to help you. So now you go to Tabitha Carview, he's a community manager, and he helps you sell your product to a community of developers. So you see here now is where you're leveraging someone. You cannot be good in all the fields. So you're just leveraging one person who is good at Angular, another one at machine learning, another one good with communities. So that is just a simple analogy. Hope you understand. So now, how do you approach this when it comes to decision forest? So let's say you put an expert in the part where the information that the first expert didn't know. So here we placed Muiti where Wayne didn't know about machine learning. So we moved on. And also, we don't expect the second expert to also know everything. That is like, we don't also expect Muiti to know everything about community management. That's where Tabitha Curview comes in. So now this is the whole idea about gradient boosted trees. So the idea is that the tree, you have different trees, but you give a tree that has a very good at one part of the data, but makes errors in other part. So in the end, now you have a sequence of trees that can come together to make a better decision because one works on the errors of the other. So I hope you understand now. It's like you have different trees. These different trees all work with on different issues that they are very good at. So now you have a very good answer because this one works on the errors of the other one. So I hope I've explained these types of decision forests in a way that we have all understood in a very simple manner that we all can get. So if you kinda understood what I shared, you can just do a thumbs up with the emojis or just reply with one in the chat section. Thank you, Laurent. You can just do a okay. Someone has their hand. Oh, okay. Oh, okay. Okay. Great. Great.
Yeah, Ndigo. Ndigo, you've got a
Okay.
question?
I think they are doing a thumbs up, but let's. Okay, okay, sure. Thank you, Ndigwa. Thank you. Okay, I can't get you clearly, Ndigwa,
Hey
but
Brian,
okay, maybe you can.
maybe
I
I
don't know.
request
I'm
you
not
repeat.
getting you. Maybe you can
Ndigo, you've
just.
got echoes on your end. We can't get you clearly.
Yeah, hi, Ndigwa. I'm so sorry. I'm not able to get you clearly. Please, if you have a query, just drop it in the chat section and I will look at it. Thank you very much, Ndigwa. So, yep. But I hope we have a clear understanding of what decision forests are. So, oh, okay, sorry, I haven't shared everything. So now we have the advantages and disadvantages of all of them because we cannot also all be good at everything. So we have cards have their advantages and disadvantages, random forests have the advantages and disadvantages, also gradient boosting. So for cards, they're interpretable. You can easily interpret what you can easily explain how you got to the decision because we have this concept in artificial intelligence that is called explainable AI. So you can easily explain here in cards how you came to this decision. And the other disadvantage is that you have lower quality results as relative. This is relative compared to the other types of trees that we have, that is the random forest, and the gradient boosted trees. And then we have overfitting. So in machine learning, have the overfitting and underfitting concept. So don't worry much about this if you're not into machine learning. Just to know that we have an overfitting. This is machine learning. This is where your model crams data instead of learning from it. The model is supposed to learn and not to cram data, but here it is where now your model crams. And here in random forests, there is no overfitting because you see, like, we have different sets of trees making decisions, then we just come to like provide one answer, to vote and then give an answer. And then you have it's example efficient, it's self-evaluating. For random forest, of course, you can easily, the algorithm that it's used, it's easily self-evaluated. But now it produces large models because you see, like, we have like at least 1,000 or 500 trees coming together to make up this model. So the models are sometimes pretty large. Then we have gradient boosted trees. So for gradient boosted trees, they iteratively predict and correct errors. They are very fast, as I shared, because one focuses on their role. Like, for example, if I'm just focusing on Angular alone, I will be able to provide a faster result compared to when I'm doing Angular, what, Django, Vue.js, all that. So this is just an analogy to help you understand it better. So they also provide excellent quality because this one works on the errors of the other one. Hence, you get a very, very better result. But also here in gradient boosted trees, overfitting is very much possible according to according to the algorithm that it uses. So yeah. So now I've talked about, so now we are done with the theory part and me giving you like an understanding of the basics. So if you want to learn more about decision forest, you can just scan this QR code, or I'll just drop this link in the chat section so that you can easily. Yep. So if you want to know more about this, you can just go. Oh, so hi Doreen. I'm just seeing a question. Is this a machine learning or data analysis session? It's a data analysis session. I just wanted to give you the basis of what just simple ML, the algorithm that it does, because we will be needing to select what model works during the simple ML for sheets when you're doing the demo. So don't feel like it's a machine learning session that matters. So it's a very short part. I just wanted to give you a basic overview. So yeah, if you want to know more about that, you can check that out. So now we go to the data analytics part. Here is where you get to analyze our data and learn more from it. So here is why use code, and no code can do the trick. So yep, I hope after this now you'll be able to use machine learning in your tabular data. That is simple ML in doing data analytics, of course. So simple ML is just an add-on to Google Sheets where you can perform different tasks. So you can perform predicting missing values in your data. You can also do spot abnormalities. You can also train, evaluate, and understand and share a model, but this is for experts. I'll just be briefly touching on this. And the good thing about simple ML for sheets is that you're bringing the tool where your data is. You don't have to move your data to, maybe importing whatever. So that is the work of data scientists and machine learning engineers. But now here we're focusing more on data analysts. So we'll be doing tasks like, oh, I'm having a simple Excel sheet, or I'm having an Excel sheet that it has missing values. How can I work around it to get better results as a data analyst? So that is what we'll be doing. But the data is also ready for classification and regression. So these are also types of machine learning, but as I said, I'll not go deep into that. So simple ML for sheets is a very good, it's a very easy to use tool. So as you can see on your screen, this is one of the demos that we'll be doing today, where you'll just be predicting will just be predicting missing values. So for example, I have a sheet that has missing values. I can go ahead and select columns I want to use, and I can easily predict all the missing values. So yeah, let me also drop this link and share it in the chat section. Okay, so now we'll be moving to the live demo part. Oh, also just to note, all the execution is on the browser and we have no servers, so your data does not leave your machine. So it is also very secure because no data is being taken away from your machine. All the execution happens in the browsers and you have no servers at all. It's serverless. So also the model is compatible with the TensorFlow ecosystem. If maybe you want, you're a data analyst and then now you want to share this, how you found the results to your data science or machine learning team, you can also easily do that. So today we'll be having these 4 demos. So you'll say we can predict missing values, how we can spot abnormal values, how we can forecast values. So forecast values was announced this year at Google I/O. So we'll be taking a look at that and see how it works, and also briefly share how you can train or evaluate a model on the same. So let's go to the first use case of simple ML, which is predicting missing values. So let me share this tab instead. So my tab should have changed to this one. Yeah. So if you're in your on your lap, not in on, sorry, Kizungu. If you're on your laptop, you can let me just share this sheet with you so that we can move together. Share this Excel sheet so we can work on all this together. restricted. Anyone with the link can view, copy link. So now, if you're on a laptop, please go to this spreadsheet and make a copy. We will be using it in the demos, so that you can easily follow along if you are. Yep. So just go to that and then we can easily follow along together. Just a moment, I pick this, please. Okay. Just a moment. In the meantime, you can make a copy of the same so that we can move together. Yep. Okay, now we are good to go. So just make a copy of that. So if you are done, maybe you can just respond with one in the chat section if you are following along with me. So you can just give a thumbs up or reply with one so that I can start. I'm just starting from the very base. So this simple ML, it's an extension. So what you do, you come here to the extensions part. I hope you can see my screen. You can see, yeah, here on the extensions part. Once you click on it, you see I have already installed Simple ML. We have Simple ML for Sheets. But now I can decide to install or start and help. So for your case, it shouldn't be there. So what you do, you just click on here, add-ons, then get add-ons. Once you click get add-ons, this pop-up will appear. So let's give it some time. Yeah, it directs you to the extension store where you are able to download. So to the Google Workspace Marketplace. So once you're here, just search for simple, or you'll see here, Simple ML for Sheets. Just search for Simple ML for Sheets, then you can click it. So for my case, I think it is installed, but let me just check. Oh, I think I used this one because it's not installed. So that I can install together. Yeah. So now I had an installed it so that I install it together with you here. So because it's a live session, so you can just click install. It will need your permission. So I say continue. Then I will just authenticate on this tab. Yep, I'm authenticating it. Just input my password. And then we are good to go. Allow. So, yep. Once I do that, you will see now I've successfully installed it. Yeah, Simple ML has been installed. The workspace now has been added, the workspace add-on. So now after that, let's just cancel this and cancel that. So there is a bug that exists on the extension side. Once you install it, sometimes you might need to again reload this Excel sheet, Google Sheets page. But you see, for my case, it is already up, so I can just click start. So are we all moving together? Just a thumbs up or a one in the chat section. Oh, someone's hand is up. That
Yeah,
is,
and Clara,
I think
you
they
have
were
a
also.
question?
Oh,
You
I
can
think
go
they're
on.
okay, and they were doing a thumbs up. So yeah. So now now we start this extension. So you just click start. You see it's working. Once it has started, it will give So you will have this on the side. Yeah, you will have what you can see it in my screen. So now let me now explain the data that we have here. So this data is data about penguins. So if you've worked on a penguins data set, you probably must have come across this. So for this data, we have the islands. So let me just explain all these features. So we have the islands where the penguins, where these results, where the penguins exist, of course. So we have the island, then we have the bill length in millimeters, the flipper length, the body mass index, the sex, and also the year in which this was recorded. So now let's say you are a data analyst and you're working on this data set, but you notice that you have missing values on the species column. So you can see in the species column, we have missing values from the first to the from the first to the 30th to the 30th row. All the species are missing. So in normal case, you would drop these values, like you say, oh, okay, I'll just drop these values since you can see I'm having like 2,000 to 1,000 rows, so it won't be that much of a loss. But with this now, you will not drop this. So you now want to predict these missing values. So what you do, you come here to predict missing values. So you see we are predicting on this species column. So you select which column with empty cells. So you see we have year, sex, body mass. So if you wanted to use any of the others, you will just select any of the others. But for us, you want to predict the species part. So I just click species. Then source columns. So you can see it even tells you the data type of the column. So you see the island is a categorical column. That's so cat means categorical, num means numerical. So categorical is a categorical value, and then numerical is a numerical value. So it tells all that. So here now, these are the rows that it will use to make a prediction. So these ones. So we'll just leave them the way they are. But in case you have a row which you think it won't have that much of an effect to your answer, so what you do, just leave it out. But for here, we'll just have all of them, since all of them are all important in our decision. So for advanced options, I'll just share. So now this is why I was taking you through the basics of machine learning, so that when you come here, you understand what we are choosing. So you can see for the learning algorithm, we have a gradient boosted tree, a random forest, and a decision tree. So here now, you know what a decision tree is, you know what a random forest is, and you know what a gradient boosted tree is. That was, I was giving you a base of everything before you get into this. So, but for us, we know that gradient boosted tree is the most accurate one. But yeah, you're not like limited to use this. You can of course use random forest, decision trees, or any other. But for here, let's just keep the gradient boosted trees and let's proceed. So for the outputs that it will give us, you have a choice. Do you want a value plus the confidence value, or a value alone? So it will just predict a value here, or a value plus the confidence. So the confidence here is how confident is the machine learning model that it is giving you the best result. So that is it. So for us, we'll just do the value plus the confident, and then you click predict. So once we click predict, let's see how many seconds it will take to go through all this data. So it also depends on the internet. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Also, we have, so mine has failed. You don't have permission to access the, oh, is this extensions? Wait, I can view this. So close. So you see mine has an error, but if you are following along, you can, please let me know if it worked on your side. You know, live demos. These are the things. Oh, it worked on your side and you have like predicted values. Okay, I don't know. So let me try with my other account. Let me try. This was just to start off, but let me just come here and then just log this with my other account. But if it has worked on your side, so good to hear that. Just give me a minute. These are live demo wahalas. This is what happens in live demos. Please forgive me for that. But I hope the thumbs up meant that it has worked on your end, right? Okay, Jacob. So yep. So here we go again. So I'll just be sharing. Ah, that's great, Collins. Okay, so I didn't want to use this sheet because it had already. So this is another sheet at all. So you can see here it worked, but this was me trying before this session, before I come and show it to you that it actually works. So let me just delete this and try again. If, oh, actually now it is. Yep. Okay, so let me just go back up and share it. Yeah, so you can see here it already predicted that the prediction, the species here is gentle, and then its confidence is 99.23. So let me just delete this whole thing so that I can do it again. Oh, I can do it again live here. But I'm so happy that it worked for you, for all of you. That means, you see, you don't even have to depend on whether my demo works or not. It actually works on your end. So yeah, let me do yeah. So I'll just go to the extensions and then simple ML for sheets, start. It's working. So let's give it a moment. I don't know if the issue can also be my internet connection, but I hope it's not. So predicting missing values, loading available labels, species. I'll not be changing anything. I'll just be clicking predict. So let's see if it works. Training a model in the browser, generating predictions. Oh, yeah, it worked. Ooh. Yeah, it has worked. So you can see here it did predictions that for this first row, it is possible that the species is, so let me just do this here. So here it's the predicted, and then let me also just do this here. So here you see it's the predicted species, and then here it's the predicted confidence. So here is the confidence. How confident is the model that this species is indeed a gento or an adeli or a chin strap? So we can see that our predictions are pretty high, and we have like 99, 91. But now let's now see. I want to delete one here and then do the predictions again and see if it will still give us the same. So I will just delete all my predictions, delete here, and then I will come. And so in line 61 or in line 62, it is a chin strap. So I will delete it. So you see, like I've deleted that. It's empty. So let's go again and make predictions. So species predict. So let's see if it will predict a chin strap. So let's give it some time. Okay, my internet connection also decided that it's going to show me Wahala during today's session, but no worries. We'll make it through, guys. Yep. So it did this prediction. Also, you can see for the second time, it's giving me 100% sure. So let's just come to line 61 and see, did it predict correctly? Did it really predict if it's a chin strap? Yeah. So you see, it predicted this as a chin strap. So now I just want to share maybe what happens behind the scenes. So what happens behind the curtain is that the simple ML will remove these first 10 parts. So it will remove the first two parts, then it will, the ones that are empty, then it will train a model on the rest of the data. And then once it trained a model, it will try to predict the ones that were empty. So you see, it will remove the ones that were empty, then train a model with the ones that actually existed, and then give you the predictions of the chin strap and all the other ones. So, or of the ones that were empty. So I hope you understand what happens behind the scenes and how it can actually help you do with your data. So let's say if you're a data analyst and you're working on this and you want to analyze this data set, but you find it has missing values, so you can easily do this. So you can say that you can easily fill in the empty values and go ahead with your analysis, maybe your BI analysis or any other. So that was the first demo. So we go to the second demo. So for the second demo, I will be sharing how to spot abnormal values. So you can see down here on your Excel sheet, we have here. I hope you can see we have the first one is the case one, which is predicting missing values. But now for this other case is spotting abnormal values. So now we want to spot which value this is, what are the abnormal values in this data set. So I had also worked on this previously just to see if the demo works. So let me just delete those columns and then see. So yeah, so here we also have a penguin data set that has the shell, the diameter of the penguin, the height, the whole weight, the shaft weight, the viscera weight, the shell weight, the type, and then the number of rings that the penguins has. But now we are noticing that it has abnormalities. So abnormalities, these are what we also call like some weird values in our data. Like you see, how comes this has 29 rings? You know, how comes it has all these number of rings? Well, this one only has 6. What is happening here? This one has 29, this one has 6. So this is a very big gap in our data that we want to understand. So now we are going to see how we can understand this. We can predict the abnormal values in the rings part. So what we do, we come here again, we do the same extension, start extension, then we do the spot abnormal values. So we click it, spot abnormal values. Then we want to check the column which you want to spot the abnormal value. So we have the longest shell, the diameter, the height. But for us, we want to see the rings. We are seeing that one has 8 and one has 25. Are they okay? So for the sourced columns, again, you can easily change or add as you wish. For the advanced options, also you can see that you have the learning algorithm. So as I explained, all of these, so you now know why you are choosing this one and why you are not choosing this one, or why you would want to go for that one. And then we say spot abnormal values. So, okay, I'll just explain what happens behind the scenes once it is done, so that we also get to understand what exactly happens behind the scenes when on the results that we have. So it's collecting examples. Hope you're also running it on your side. If your side has already worked, you can just reply with a thumbs up. If it has already done all this on your side, I don't know, but I think it's an issue with my internet. It shouldn't be taking this long. But let's just be patient with it. So you know that maybe when you're doing data analytics, sometimes you have these abnormal values. And most of the time, when dealing with abnormalities, you might decide to just remove them. But there's a whole lot of ways you can deal with it. But now you see, with simple ML for sheets, it helps with analytics. It can tell you what exactly is the right value for the number of rings, and also the prediction score. So like, how correct is my data? How correct is this prediction? So let's just wait for it. I don't know why it is taking that long to just run. If it has it run for any of you, you can just reply with a thumbs up. Or for Collins, it has already run. I don't know. I think it's just an issue with my internet today on this demo day. But this is what happens when you are doing demos, live demos. But yeah, let's just be patient with it. So it's still running. I don't know. I'm tempted. I'm tempted to refresh things, but let's just be patient with it. So it is as it is. Oh, it's okay, Ian. I'm so sorry that you are not able to follow up. But what we can do is, this session is being recorded, and you can you can always come back to it. But if you want to just follow, what you're doing now is you're spotting abnormal values here. So what you're seeing is that, for example, here I shared that you have 6 rings here, but here you have 29 rings. So which is which? Is this one okay or is it not okay? So that is what you're trying to do. So it has finally worked. Okay, so the gods of my internet have finally decided that it is working. So let me just now do a deep dive explanation. No. I'll do that later. So let me just expand this so that you can see. So you can see here, the predicted abnormality is 0.999 and this one is 0.9. So we have here, it is saying that it is most likely to be 11. And you can see that Simple ML has given us these digits in raw, like all the predicted, it hasn't like rounded them off to a nearest number because they want to give you all the power. Like you can decide to edit this as much as you want. So now here, let's see. Let me just come here and let's check the ones with the highest prediction. So let's sort this from A to, from A to Z. Oh, here we're checking the ones, no, from Z to A, yep. So, okay, so you can see that these ones are the ones with the highest accuracy. So you can see that for the first one, it says that this is the abnormality, at least this one should be 11. So you can just go down and see that this one is 0.8, 0.6. So if you're working on this data set and you have such abnormal cases, you can decide as a data analyst, maybe if it is above 0.5, then I will change the values to these predicted values. But if it is below 0.5, probably this is something that is accurate and something that is not accurate, and I'll just leave them the way they are. Or you can just decide to always check them, all that are predicted to be. So you can say that you can decide to change all the values that were thought to be wrong and leave all the other ones. But you can see here, for all those that are not wrong, you can see at least you have 6, 8, 10, it's on a range of up to 20. So, yep, that is how you spot abnormal values with Simple ML for sheets. So that was another demo. Hope it has worked on your end. I don't know. Just let me know. I know for Collins it worked. Just do a thumbs up or one in the chat section if it actually worked also on your end. I know for many others it is okay. Okay, that's great, Ian. Okay, so that was the second demo. So let's go to the third demo. So in the third demo, we'll be forecasting values. So I want you to come to case number 4, where you're forecasting future values. Down here, you can see that we have case number 4, forecast future values. I think I also forecasted these ones. Yep, I already did a forecasting on this one. Okay, but let me just redo everything. That up. Okay. Yep. So you can see that in this data set, we have, so let me just give you an explanation of the data set. So in this data set, we have dates and a value. So let's assume that these are the dates and the value is the number of customers that you receive in your hotel. So you want to predict, you want to stop wasting food in your hotel, and you want to try and predict how many visitors will come in the coming days so that I have less predictions. Or as a data analyst, you want to also see future values. And when you're presenting, let's say, your BI report to your managers, you tell them, also, I did forecasting, and probably during the recent days, since it's almost nearing Father's Day, which is tomorrow, we'll be seeing a rise in buying of more fatherly items or more rose flowers because it's Father's Day, or we'll be seeing a rise, but it will not be that much compared to Mother's Day because that's how we have been seeing it. That is just an example. I'm not being biased. So, yep. So let's just see. Now we want to predict the value. So you can see here for this part, I've left some of the dates. The dates down here, we don't have values for them. So you can see, yeah, from 1961, the 7th, yeah, 1961, we don't have values of it. So we want to predict these values. So what we do, we just click forecast future values, and then you are predicting the value column. Then you have column categories, so we don't have like that much of a category here. We also have advanced options. So for the trend here, you will be able to see, you see what I'm having here. So we know that Excel sheet and Google Sheets are normally visualization tools. So this visualization tool will help us to understand, are the predicted values working according to how we wanted or not. So yeah, also the growth, the seasonality mode, the seasonality effect, the cleaning, the holiday. So these are some of the features. You can just check them out in the documentation. I wouldn't want to give you so much of machine learning terms in this session. So yep, so let's focus our values and see. So this is what you already have. You can see from this graph, it's already what we that exists. Like you can see, we have from 200 to 400. It's not always like not. It's not predictable. So it's updating the sheet. Okay, let's just wait for it. So value, predicted value. I don't know. Let me see. Oh, okay. It has predicted successfully. But on your end, this graph should be different. Okay, so you can see here, it has predicted these values from 1961 for us. It has predicted them for us. So you can see, instead of you going blindly on what is coming as a data analyst, maybe you can easily incorporate this in your workflow. And also you can share this with the data scientist or machine learning teams and share with them, because you can even get the model that did these predictions. Are going to see that later and see how it worked. Also, you'll get to see the seasonality graph that is on top of it to just understand how are the values, how are they explained. So yeah, also just checking in, did it work on your side too, or do we have any queries probably on your end? Oh, for Tony it worked. So yeah, for Collins also it worked. So yeah, you can see, like, it makes the life of a data analyst so easy. It streamlines your workflow in a very, it makes stuff so efficient. So yep. So that was the third demo. Oh, I'm so sorry. You have a lot of demos today. So on your own, please just go and try doing forecasting for multiple values. So I had already done forecasting for these multiple values. So this is just the location is in London, New York, New York. The department is toys, books. So we're trying to predict how many of them are going to be bought or are going to be sold this time. So you see, you can just now go and try this on your own in the essence of time, of course. I wouldn't want to keep you that long. I understand it's on a weekend. So I did this before the session, and you can see here we have this predicted value. So it's just similar compared to it's just similar like how we predicted simple one value, one value. So here we're just predicting many values, and you can see it here. So now we want to see if, let's say, I want to, so now this is for those probably who have more understanding in machine learning concepts and want to see, okay, what model did it build for me? So now let's go to training dataset, in this case number 3. Oh, how did I make the extension enabled? So to make the extension enabled, you have to, I think it's a bug. We have a bug on the extension side that when you just install it, sometimes if it's the first time, it doesn't work. So you have to reload the sheet so that it works. But yeah, so now let's see. Maybe I'm a data analyst. I just want to work and play sometimes. I just want to see how did the model come about. So what I can do is I can just come here. So you see it is even in the advanced task. So in the advanced tasks, you can train a model, you can make predictions, you can evaluate, you can understand. So in our case, let's train a model. And for this model, I'm going to call it Speciatech session. Speciatech session. Yeah, Speciatech session. So that is I'm going to. So for the label is what am I predicting? So I'm predicting the species again, as I said. Then these are the values that I'm going are the features I'm going to be using. And then which model am I doing? Am I doing a gradient boosted model, a random forest model, or a decision tree model? So here I'll be doing a gradient boosted tree model. Then I click train. So once you do this training now, what it does, it builds a model and then it saves it in your Google Drive folder, in your Google Drive in a folder called Simple ML for Sheets. So once I've built this model, I'll be able to go to my, you see, it only gives me silent treatment, like task completed with success, you know. And so if I want to see this model, I can go to my Google Drive, and so I'm just opening my Google Drive a moment so that I can show it to you. I can go to my Google Drive, and then after that, I click Simple ML for Sheets. So I'm just opening it so that it is okay with all of you. I'm just opening it and I'm going to want to share my drive with that. So, yep. Okay, so now let me share this tab. So hope you can see this tab. So you can see here, I have the Speciatech session model saved here. So if I want to access it, I can easily access it. But you see all of the predicted I had been doing, all the predicted missing values, the models are actually being saved in my drive. So I can easily check them up. So I wouldn't want again to bug you with lots of this. So I will just go back to this tab. So I'll just close. So now you can see that we did our training. So if you want to know more, I dropped the link to the documentation in the chat section. You can always look at it. And then now we can make predictions. Oh, no. So let me now share. They're not saved as .py, but if I want to export that model, what I do is I click here. You see there's an export model part. I click export model and then destination, Google Colab, and then I click export. So when I click export, it is exporting my model and then you will just see it here. So yep. So now I can share this. So you see sharing model. So copy and execute the following code in a new Google Colab to run the model. So I can easily run the model with this. So like everything is already here, and then you can just easily go and check. So you can open Google Colab Notebook, then copy this and execute it. But if you're using Kaggle notebooks, you won't need to run this decision forest, this TensorFlow decision forest, because it is already installed on Kaggle notebooks. But if you're using Google Colabs or Jupyter notebooks, you will have to download the extension. Also, you can see that it has already noted where my model is, and you see I named it Speciatech session, and here it is. So yeah, that's so I think I've done all the. Also, let me just share the evaluating a model. So now I want to, let's say I'm sharing this with my data team, my data scientist team or my machine learning team. What they can do is they can actually come and evaluate my model that I use to predict this species. They can click evaluate. So these now are terms and techniques that the data scientist and the machine learning team easily understand. So because I didn't want to give that to this was a session on data analytics. So yeah, so you can see here we have the number of predictions. It gives you the accuracy. So you can see we had a 97% accuracy, which is kind of good since we didn't. It also gives you the loss, the error rate. Also, it gives you a confusion matrix. For those who understand, confusion matrix just help you to understand how good is your model and the true positive, false positives. So I don't want to just go details into this, but just to share with you that you can actually do this. We also have, you see the ROC graphs down here, the precision, the recall on all of these. This is just a whole other session if I want to cover how you can use simple ML for sheets as a data scientist or as a machine learning engineer to get more insights on your data. So up to there, just wanted to, are we all together? Did they all work? Or if so, we did, so let me just slide show. We did the first use case together. Then we did the second use case. So we did the first use case, which was predicting missing values. We did the second use case, which was spotting abnormal values. We then did the third use case, which was forecasting values. And the fourth one, which was training and understanding a model. So now this is just a summary. Okay, before I continue with the summary, the demos all worked and we are all good. You can just do a thumbs up. The extension, okay, thank you, Jab. It's okay, thank you, Collins. Thank you, Collins. Thank you, Jacob. Oh, thank you, Samuel. So, okay, someone has a question in the chat section. It's not overfitted. It isn't a 97% model overfitted. So that is why you have the evaluation part. Now, when you evaluate your model in the part where you had confusion matrix and all the recall and precision graphs, this is where now you get to understand, is my model overfitted, or is, because I presume as a data scientist or a machine learning engineer, you already understand the concepts of confusion matrix and the precision and recall and also accuracy. So you can easily juggle and see, was my model overfitted or not. That's why I said that is a part that is maybe for the ones that have deep knowledge. But since today, I didn't want to scare away anyone because it's just a data analytics system. But yeah, if you have any more queries, please just reach out to me. I will share that in the next. Hope I answered your question, Tony. That is Tony Change, I guess. Yep. Hope I got your question. Yep. So, okay. Thank you very much. So, just to give a summary of what we've talked about today, Decision Forest is an easy and powerful solution for tabular data. As we have seen, I'm able to get predictions. I don't even need to use, neural networks or anything. So, this is just to tell you that you can just be simple, in your workflow and still get good results. We also have good results with default parameters. Also fast training and inference. If for Collins College, I'm sure you're using very fast internet. So the fast training and inference is all we were out for, and we managed it. And machine learning without the need to learn how to code. You can do all that without even writing a single line of code. Even the model, the code for everything was already written out for you. So that is, you see the goodness that we have. So now for the resources, you can go to the official site here. I think I dropped this in the chat section, but let me just share it with you again so that it is, yeah. Let me just drop it here and also drop this course. So if you want to know more about machine learning, no, not about machine learning, but about decision trees, that is how to go about them, you can go to that course. It is so helpful. It explains everything in a very, very simple manner. Okay, now it's time for question and answer and feedback. So I really want to get your feedback so that I can make my other sessions more exciting. So please, you can scan this QR code, or let me just drop a link in the chat section. Yep. So let me drop this link in the chat section. Please just go ahead and fill the form with the feedback as I take in your questions. Yep. So copy, then slideshow. And now back to the meeting. So yeah. Yeah. So thank you everyone for joining today's session. Please, please, please help me fill that feedback form as I take your questions. So now, any question? Now it's a live Q&A. You can unmute, you can even open your video and ask me a question. I'm here to assist if I've mentioned something you didn't understand, or if you have like, your own data set and you're wondering, okay, if I'm to use this on this data set, how is it going to work? Also, just let me know. Time for Q&A. Any question? Okay, what did you love about my session? Let me not. Yeah, someone has Francis' hand is raised. Francis' hand is raised. Hi, Francis.
Hello, Kai.
Hi.
Yeah. So I have a question.
Yes.
Uh, Based on there was a point actually you converted the the spreadsheet into a code, like hiyo place kuna venye sikuelewa vizuri.
Oh,
Yeah,
okay.
like importing it to the notebook.
Oh, okay. I think you have the same question as Lillian Bone. So Lillian Bone is also asking, how did you view results after you train a model? I got lost. Okay. Hi Lillian, I hope this will answer the question. So let me just come back to the part where we did that. So the training, the training data set. So here I am training this data set. So you can see that this data.
You are showing a different screen.
Oh, sorry. Let me share this tab. Now you can see, hey, sharp. We have sharp boys. No, we have sharp developers. I'm so sorry for using the term boys. We have sharp developers in the session. Very sorry about that. I didn't mean to demean anyone. I'm very sorry. So here you can see in this data set, everything is okay. Like all the species are there. You can see like all the species are there. Apart, we just have a few rows that have missing value. For example, you can see you have a missing value, and so this is a full one. So what we are doing here, we want to train a model with this data set, and we are calling our model the special text session, but you can call it any model. So you see these are other models that I also came up with, but our model we call it special text. Then after that now, so this only means this is the model I'm training that I'm going to predict with in I'm going to predict the values with. So this is mostly for if you want to actually now build the model. But also for the other sessions, when I was clicking predict missing values, it was actually building models for me. You are not able to see that part. Oh, Google Meet is not showing you this part, but we have other models. So let me actually select another one. So you can see here, we have predict missing species. This model was built on the 6th, 10th, so 8:54 p.m. So even when you're doing the predictions, the model is actually being built and stored in your Google Drive. So what you can do is you can actually go and check the model. But now when you come here now, okay, so for these other ones though, the predict missing species, it is only building the model on the values that are full, like the ones that don't have missing values, and the other ones on top are left out. But when I come here in this sheet, all my values are there. So when I say build a model, it will build a model on all the values. So now when I want to export this model, so you come here and then you say export a model, then I click, I'm exporting to Google Colab. I think now we only have the option of exporting to Google Colab. So it's downloading, download model, it's collecting examples, it's building a Colab example, and then it is doing this for me. So now this is my model. So you can see import TensorFlow as TF, import TensorFlow decision forest as TDF. So tf.keras.this model to keras. So all that model TensorFlow. So these are now the aspects that I hope all of us can understand. I didn't want to go deep, but I can also. So now, what you do here is you click, I want to do a new column session. So once I click that, it opens here. So let me share this tab. So now it opens this Google Colab tab. It is still loading. Yeah, it is loading. So now once it has loaded, so you can see it is displaying all this. So these are some of the collabs that I already have. So what I do is I just say, let me just create a new notebook. When I create a new notebook, let's go to the new notebook, which is here. Now I can export that model because you see the way it is explaining to us that copy and execute the following code in a new Google Colab to run this model. So what I do is just I copy all of this, copy, and I paste it. Now I paste it here. Now from here, I can make all the changes I want. I can bring the data set and import in DF underscore CSV, all that, and then see how it actually works. Oops, sorry, I'm sharing the wrong tab. Wahala. Okay, now you should be able to see this. Yep. Now here, I can do all the changes I want. I hope this answered your question, Francis. Or what exactly was your question?
Uh,
Oh,
yeah, yeah, thank you. Actually, I think I'm now okay.
okay,
Yeah.
nice. Sharp developers, we have very sharp people in there. Well, I'm so happy to have all of you here. Hey, okay, Lillian, did I also answer your question? If you're okay, you can just unmute or just drop a one in the chat section if your question is answered. Oh, thanks. Thank you, Lillian. I'm so happy you joined the session. So, yeah, let me go back to the slides now and take any other question. Okay. Now, as you continue giving me feedback, and as I continue receiving your questions. Any other question that we have? Feel free to just unmute and ask your question. Or maybe what did you love about the session? You can just share. Yeah, I'm also so happy that you all joined us and you stayed to the end. I really appreciate that very, very much. So, yeah. Oh, I'm just here for
Okay.
Q&A. Hi, Jimmy.
Hi, Brian. It's fine.
Hi,
Uh,
I'm fine.
I'm seeing some feedback here by someone by the name Ian. Ian, do you have some feedback for us?
Oh, okay. Let me just.
Okay. Ian is asking for your Twitter handle, and Francis is asking, is it possible to train a model to identify images using the simple ML?
Yeah. Okay. So for Ian, I've just dropped my Twitter handle in the chat section. It's at Kai_Manyumba. Yep. Feel free to reach out. Yeah, my DMs are open. For Francis, for now, it is only limited to tabular data because this session was only focusing on tabular data, and also for simple ML, it is not able to, because you see it is working on Google Slides, on Google Sheets, so it is not able to give you an explanation of like image data. But what we can do, this is actually a nice question. I can plan another session with Spacia Tech where I can share with all of you how you can train a model to identify images using TensorFlow and other libraries for machine learning. But for simple ML, right now, it cannot support images. But you can use TensorFlow, you can use Keras to build computer vision models that are able to do that. But we can also plan a session with Spacia Tech and talk about that. Also, in the feedback form, there is a part where I've said, if you want me to talk about any other session, please drop that. Also, any sessions, please drop that in the chat section, and I will of course I'll of course follow up on your feedback. Also, and then Lillian is also asking, will there be more other sessions in future? Yes, Lillian, we will have more of these sessions in future. maybe what session would you love me to talk about? And I'll just plan with the Spacia Tech team, and we can, of course, either me or any other speaker, of course, can just come in and share their knowledge on the same. But if you have a specific session, you can leave that in the feedback form that I'm sharing on my screen right now, and also drop it in the chat section, and I'll of course do that. Also, Tony is asking, running code on Colab, I get a funny error. Okay, yeah. So you can get a funny error because you have to like understand. You have to like there's a way you can tweak this because it says from Google Colab import drive, yeah, from .mount CP Google Leverage content specific text session, prepare to load the data, yep, terrace this. So maybe I wouldn't want to go deep into the error that Tony is getting. But hey, Tony, just reach out to me and we can now dive deep into that. Is that okay, Tony? Yep. I wouldn't want to. So, because that is a whole session on its own where we'll be talking about how to understand those models and do all that. But hey, but Namburi wanted to help you out. Maybe you can just drop the error you are getting. I hope I'm pronouncing your name correctly.
I'd wish to know the funny part, not the error part, the funny part of the error.
Yeah, they just shared it. Warning: TensorFlow autograph could not transform function ML inference up with handle at this and will run it as is. Okay. Okay, there's he has dropped the error in the chat section. It's a warning. So in errors, we have different types of errors. So one can be a warning, it's at the warning level, or one it stops the things at all, but that is just warning you, trying to tell you that TensorFlow autograph could not transform that function and it will run it as it is. So yep, it's more of just a warning to it's just notifying you, hey, just to let you know that this is what I'll be doing. Yeah, but of course, reach out and we can do that together. I'm very much okay with helping you out. Yay. So maybe I just want now to hear from all the 17 that are in this room. Just
okay, Brian, I'll be taking it over from here. I know Juma is having some technical issues I won't mention. But I hope the session was nice. So I hope it was informative for those who joined. For those who stayed with us from the start, thank you guys for being with us through this session. And
Hello.
yes, Juma, I can get you. Okay, sorry. So Juma, if you are at liberty to speak right now, just go for it. Yeah. I thank Brian. You know, maybe we haven't interacted, but we at Spacia Tech we are a big team. I know there's also someone behind the Spacia Tech account right now. She's a she. I won't mention more about that. And we. Okay, someone is saying something. Okay. Brian, you've gotten the feedback form. Are people filling in the form?
oh, okay, let me just check it out. I always don't want to pressure attendees to fill the form, but I'll just drop the link in the. Let me just check it out right away. Yeah, let me just check it out later. Also, I will share a repository with all the resources for this session. I will also tag Spacia Tech and everyone, and of course, if they're emailing you back after the session for everyone who RSVP'd, I will send them the link to the repo, and then they can, of course, share with you all the resources they have, like the documentation and all of that. So don't be worried about that. I will share even the slides with all of you.
Okay, thank you. Thank you. I'm also just a reminder for those who haven't followed us for someone who joined maybe in the middle of the session. The session was recorded and we'll have it posted on our YouTube channel. And okay, let me just stop reading because the texts are distracting me. And we'll also share some of these links that Brian will be sharing. Okay. I'd wish to also just briefly share something about our Mentalist platform. So I don't know whether Brian, you can just let me just give a brief presentation.
Oh yeah, let me just stop
Yeah.
presenting. That's very much okay.
Okay.
Or stop sharing. Yeah. Also, there's someone in the feedback has shared in the feedback form in capital letters that I hope to have more sessions like this in the future. So yeah.
Yeah, Juma, that is on your that is on your court. You will plan more sessions. I know for this month our schedule is slightly packed. Maybe we'll push it. We'll see how we can just fill the sessions in. Okay. Okay, so I know as we were starting, someone mentioned about the Mentalist platform. Someone say that this session is brought to you courtesy of Speciatech and Mentalist. So I just want to give a sneak peek of what Mentalist. Now some guys just say we speak about too much on Mentalist and we only sharing a wait list. So what is Mentalist? What does it actually do and what does it look like? So this is just a sneak peek. Juma, we are recording. It's just fine. Thumbs up, thumbs down. Okay. This is how the Mentalist platform looks like from the onset. So this is a prototype. So I'll just be going through fast enough. So this is the first thing you get when you're signing up. After filling the form, it gives you a dashboard where you can actually see these are mentors. You can actually choose a mentor for yourself. And after you've chosen a mentor, I'll just go with the flow how the flow is meant to go. You can actually book a session. You can get to book a session with a mentor and get to actually join those sessions that you booked. You can actually get to actually network with other guys. I know that isn't up. Okay. I'll just go back to the overview page. Okay. So on the overview page, this is what basically we having. So you have a search bar for you can actually search anything. You can search for mentors, you can search for mentees, you can search for your sessions and such like things. These are sample search. So someone is searching for software developer, so you can actually filter them through. So this is how your profile looks like when you're checking a profile. So I'm just brushing through the how the Mentalist looks like, so that someone who has never really gotten to know what we're speaking about. So this is our it's our mentorship platform that we're developing. So we are trying to get people to actually get to, what do we say, to get a one-on-one interaction with their mentors. Like someone can have, like Brian here, who was having a session tonight. You can maybe say you want him to mentor you on a specific topic and he is already on the platform. You can actually search for him on the platform and get to book a session with him. So that is basically what Mentalist is all about. And I'm just brushing through as I'm speaking. So there's also for a view for for mentors. I think I don't have the view for mentors, but this is basically how someone who is joining as a user for the platform, a mentee. This is basically the flow. Thank you. Should I decline? I should just decline. Okay. I hope you got that. And if you're interested, and that's your mentor. Okay, Juma, you're saying you're the mentor, so that is not you. I know your photo. Anyway, that was all for this session. And we thank you guys for joining in, and we'll be planning more sessions like this for the future. I think that is all I have for now. So in case you have any feedback, you can reach us on our socials, Twitter, whichever platform you choose that we are on. Thank you.
Hello. Someone confirm that I can be heard? Yeah. On my end, I want to thank you everyone for joining and taking time to join this session. Thank you, Brian, for taking your time to share with us your knowledge with us. Then, for those requesting for another session, next month, I think before the end of next month, you're planning something on. I'll be planning something on data, so be checking out on our social platform for the same. Then for the devs next week, you're planning something to do hands-on coding. So just check out on our social platform. I'll to know you are speaker on the next week event. So that is it on my end. Remember to join our waiting list for the pick to have a test of a better version of Mentalist.